Today's episode is about camels. Now, when we mention camels, the first thing that comes to mind is ships of the desert, right? This is the camel's biggest label and also their most remarkable feature, because the desert environment is truly deadly. Here, you not only have to face extreme heat and extreme drought, but also endless sandstorms. And vegetation is extremely scarce. There's hardly anything to eat. If we're talking about the most unsuitable environment for survival on Earth, deserts definitely make the list. So the fact that large mammals like camels have ways to survive in the desert seems particularly incredible. For example, someone once did an experiment and found that under conditions of no food or water, camels can still live for about 2 months. And if they only drink water without eating, they can even last 3 to 4 months. It's quite absurd. However, many people might be so familiar with camels that they think it's natural for them to live in deserts. Instead, they overlook just how remarkable this actually is. In fact, if you look at all the adaptations on camels' bodies, their ability to do this is simply like a miracle. Especially when it comes to utilizing water, you could say not a single drop of water is wasted by camels. So how do they do it? It's really super exaggerated and extremely ingenious. We need to take a good look at this. And then another thing, camels as livestock might not be very familiar to us here, but in the arid and semi-arid regions of Central Asia, West Asia, East Africa, and North Africa, camels are incredibly important, much more important than pigs, cattle, horses, and sheep. Besides serving as ships in the desert for transportation, camel meat, camel milk, and camel wool are all indispensable survival resources for locals. And recently, scientists have also been discussing whether camels as livestock have been underestimated. Especially with climate change trends, many places might become increasingly dry and hot. Some pastures are gradually desertifying and are no longer suitable for cattle and sheep. Could switching to raising camels be an option? It's definitely a possibility, right? So last year, the FAO, Food and Agricultural Organization of the United Nations, designated 2024 as the International Year of Camelids. You can see from this that the trend is to elevate their importance as livestock. So today's episode, we're going to talk about the legendary story of camels.
Now, although both characters in the Chinese word for camel have the horse radical, camels are actually quite distantly related to horses. Horses belong to the order Perissodactyla, odd-toed ungulates, while camels belong to the order Artiodactyla, even-toed ungulates. And within Artiodactyla, they are a special evolutionary branch called Tylopoda, pad-footed. What does pad-footed mean? You can understand it as having calloused soles on their feet. For example, other branches of Artiodactyla, like pigs, deer, and cattle and sheep, all have very hard keratin hooves, but camels have callus-like meat pads that are wide and thick. This is pretty obvious, right? If they had cow hooves, it would be like walking on a beach in high heels. Only this kind of wide, large, thick pad doesn't easily sink into sandy ground. That's why they're called Tylopoda. Now, the only extant family within Tylopoda is Camelidae, and Camelidae is divided into 3 genera: Camelus, camels, Llama, llamas, and Vicuña, vicuñas. Among these, llama and vicuña are both native to South America. We covered them in the previous alpaca episode. The genus Camelus is primarily native to Asia and Africa, which are completely separate regions. However, if you just look at their faces, those South American cousins actually look a bit like camels, especially llamas and guanacos. Both in body shape and appearance, they have that camel vibe. It's just that they don't have humps on their backs. That's an obvious difference. Now, what's somewhat unexpected is this. The ancestral homeland of Camelidae is neither Asia and Africa nor South America. It's actually North America, where no Camelidae species currently exist. About 50 million years ago, the earliest camel called Protylopus appeared in North America. However, this ancestor was also the smallest camel in history. It was only as big as a sheep, but had particularly long legs. It lived in forests and could stand on its hind legs to eat leaves. Just like the okapi we discussed in a previous members-only episode. It didn't look like a camel at all. However, its later branches grew larger and larger in body size. Then about 6 to 7 million years ago, one branch wandered across the Bering Strait and arrived in the Eurasian continent, becoming camels. Another branch about 3 to 5 million years ago crossed the Isthmus of Panama and arrived in South America, becoming llamas. Both of these branches have survived to the present.
However, the North American camels, like many large mammals, didn't survive the Quaternary extinction event. At that time, the last camel in North America was called Camelomps. We mentioned it in the saber-toothed tiger episode. It was also a favorite of saber-toothed tigers. As a result, 11,000 years ago, it went extinct along with the saber-toothed tiger. So that's why there are no camels in North America. That's the story. Now, the genus Camelus that arrived in Asia, Africa, and Europe currently has 3 extant species: the dromedary, one-humped camel, the Bactrian camel, two-humped camel, and the wild Bactrian camel.
Among these, both dromedaries and domestic Bactrian camels have been domesticated by humans. Their wild ancestors are already extinct. Only the wild Bactrian camel is a genuine wild camel. They live in some desert and Gobi regions in northwestern China and Mongolia. However, their current population is only around 1,000, even fewer than giant pandas. They're an endangered species, and the situation is not optimistic. In comparison, those camels that wear bells and mix with humans have much more prosperous populations. According to FAO data from 2023, there are approximately 42 million head. Among these, dromedaries account for 94%, mainly in Africa and West Asia. Bactrian camels account for 6%, mainly in Central Asia, northwestern China, and Mongolia. These are all regions with particularly arid climates and extremely harsh environments, and the roles they play cannot be replaced by other livestock. So next, let's talk about the secrets of how camels can adapt to desert environments. Now, first of all, the camel's most powerful equipment is none other than their iconic humps. Everyone knows that humps are used by camels to store energy. When there's food available, they eat desperately, converting food into fat and storing it in their backpacks. So when the hump droops down, it means they haven't eaten enough. When the hump stands upright, it means they have sufficient reserves. Then, when crossing the desert for a long time without food, they rely on the fat in this backpack to get through. And another thing, besides producing energy, fat metabolism also produces water. So humps are really very important for camels. However, there's a question here. Among all the animals in the world, why do only camels have this kind of energy backpack structure? We need to talk about how it came about.
Actually, many animals in the world need to store large amounts of energy, especially those in the polar ice and snow of the North and South Poles. For example, polar bears, penguins, seals, narwhals, and belugas all have large amounts of fat on their bodies. It's just that their fat is mainly subcutaneous fat. They wear the fat on their bodies. Besides storing energy, it also provides insulation and warmth. It serves two purposes. But for camels, if they wore fat all over their bodies, wouldn't they die of heat, right? So there's no choice. They can only concentrate all the fat in one pile and carry it on their backs. And in such a hot environment, to store so much fat, this might be the best method. That is to say, the camel's unique survival mode created their unique humps. That's the story. Then, besides the humps, the desert's high temperatures forced camels to develop some other adaptations. For example, everyone can feel it. Their legs are particularly long, 4 long legs. Logically speaking, camels don't really need to run very fast. When crossing deserts, they mainly rely on endurance, not speed. So why are their legs so long? Well, it's speculated to also be because of heat. In summer, the surface temperature of sand can be much, much higher than air temperature. It can even exceed 70 degrees Celsius. It's extremely scorching. So with longer legs, the body can be as far from the ground as possible, with less heat radiation. This is the benefit of long legs. Then, additionally, camels have another very special structure that people usually don't notice. At the chest position, there's also a particularly thick tissue pad like a callus. It even protrudes from the chest. So what's this thing for? Well, it's also related to heat dissipation. When camels get tired from walking, they need to lie down and rest. At this time, if their entire belly were plastered on the scorching sand, imagine how miserable that would be, right? Then with this protrusion on the chest, plus calluses on their front and back knees, camels can lift their bodies up a bit, leaving some space between them in the ground. This allows for ventilation, which can cool them down considerably. It's also a little trick. Then another thing, the fur on camels' bodies is also very dense. Some viewers say, wouldn't this make them hotter? Well, actually not really, because the desert's high temperature is often even higher than the camel's body temperature. At this time, that coat of fur isn't for keeping warm, it's for keeping cool. Research has shown that when camels' fur is shaved off, they need 50% more sweat to dissipate heat. This shows that the fur does indeed have an insulating effect. And another thing is that the desert also has the problem of large day-night temperature differences. At night, camels also have warming needs. Especially for Bactrian camels, their region also has extreme cold in winter. The coldest weather can reach negative 30 degrees Celsius, so the fur on their bodies is much longer than that of dromedaries. In winter, they're wrapped up tightly. Then when spring comes and temperatures rise, they shed a layer. For example, those camel down products on the market are actually collected before Bactrian camels shed their fur. It's said that one camel can yield about 7 kilograms of wool at a time. You can see how dense their coat is. But the desert's scorching heat and extreme cold are one thing. Actually, the biggest challenge is lack of water. So regarding the water issue, camels have taken it to the extreme. It's simply obsessive, using any means necessary. Let's continue. We just mentioned that when camels have food available, they eat as much as possible, converting it into fat stored in their humps. Well, when there's water to drink, it's the same. They'll drink their fill at once and store the water.
And the volume and speed at which camels drink water is really quite exaggerated. They can often drink 100 to 200 liters of water in just 10 or so minutes. That's about 1/3 of their body weight. Now, this water isn't stored in the humps, so where does it go? Well, this is an incredibly remarkable aspect of camels. They store water in their blood vessels, essentially diluting their blood. Turning blood vessels into water pipes to store water, it's quite absurd. Now, at first hearing, this might not seem like much, but for living organisms, this is actually extremely, extremely dangerous. For example, if a person drinks too much water in a short time, there's a risk of water intoxication. There was once a case where someone drank 6 liters of water in 3 hours and died. It was due to water intoxication. The reason water intoxication is fatal is that large amounts of water dilute the blood too much, causing hyponatremia, low blood sodium. Eventually, excess water enters brain cells, causing cerebral edema, which is life-threatening.
And another thing, if blood becomes too diluted, red blood cells absorb water and swell due to osmotic pressure and can even rupture. This can also be fatal. These are all risks of drinking large amounts of water in a short time. So, coming back to camels, why can camels drink 1/3 of their body weight in water at once without any problems? Well, it's because their red blood cells aren't ordinary red blood cells. Camel red blood cells aren't round, they're oval-shaped, and they're particularly elastic. When blood is diluted, they absorb large amounts of water but don't rupture. They can even swell 2.4 times without problems. So camels can safely store water in their blood vessels. On the flip side, if they go a long time without drinking water and the body becomes dehydrated, camels are also exceptionally resilient. For mammals in general, dehydration of about 12 to 14% can be fatal. Because blood becomes too viscous, red blood cells deform from water loss, can't flow, and the animal suffocates. However, for camels, it's different. Those oval red blood cells, even with 30 to 40% dehydration, can still maintain their shape and flow normally in blood vessels. That is to say, camels can drink water freely when available and can also withstand dehydration. This is a superpower that other mammals don't have. Of course, besides drinking more water, increasing input, camels also need to conserve. They need to be good at saving water. How do they save? First of all, they need to sweat less. Now, everyone knows the function of sweating, right? It lowers body temperature. When it's too hot and body temperature is about to rise, sweating occurs to dissipate heat and maintain body temperature. To sweat less, camels came up with an extreme solution. Just let body temperature rise freely. Don't worry about it, just don't sweat. So during the day, a body temperature of 40 degrees Celsius is considered normal for them. Then at night, dropping to 34 degrees Celsius is still normal. Body temperature can fluctuate up and down by 6 degrees. There's nothing like it. Observations say that temperatures need to reach about 49 degrees Celsius before camels start sweating. It's quite absurd. However, everyone who's had a fever knows that when body temperature is too high, you definitely get a headache because it causes intracranial blood vessels to dilate. So camels can ignore body temperature, but they can't ignore brain temperature. How do they manage it? Well, camels have 2 little devices, very ingenious. First, the first device is in the nasal cavity. When animals exhale, water vapor inevitably evaporates from the lungs. Camels don't want to waste this water vapor either. So in their nasal cavity, some curled mucous membranes have evolved that look like bacon rolls. When exhaling, about 60% of the moisture condenses on these bacon rolls and is retained. Then, when inhaling, this moisture evaporates again and returns to the lungs. It's such an ingenious structure. And this structure has another function. Evaporation absorbs heat, which can locally cool down the bacon rolls. The temperature of the blood inside drops. Then, this cool blood next enters a network structure and intertwines with arterial blood, exchanging heat to cool the arterial blood. So where is this arterial blood going? Everyone should have guessed it. That's right, it's going to the brain. This is how camels cool their brains. They both recover water vapor and cool the brain. You could say it's very ingenious and very perfect. Of course, conserving water has one last important part: urination. Camel urine is already as concentrated as it can possibly be. It's almost like syrup, and when it's expelled, it must flow down their legs. Why? When it evaporates, it cools them down even more. Really, not a drop is wasted, right? And then their feces, as you can imagine, are also particularly dry. It's said they can be lit directly and used as fuel. That's how dry they are. So even in terms of excretion, camels have taken water conservation to the extreme. They're good at both increasing input and conserving output. This is the secret of their super drought resistance. Now, camels actually have another special ability that's often mentioned. They can smell where water sources are in the desert. A study found that they're particularly sensitive to the smell of a certain bacteria in wet soil. When there's wind, they can smell it from several kilometers away, so it's easier for them to find water sources. This is also a very useful ability. And where there's water, there's food. However, everyone knows that plants in the desert basically don't have lush foliage. Most are particularly short and often have thorns. So to deal with these extreme foods, camels' mouths have also been enhanced. First of all, their lips can extend very long, and the upper lip is split in two. When eating, they can grasp food like 3 fingers.
Then another thing, inside their mouths, the inner walls of the oral cavity might shock you because they're densely covered with sharp spines, just like alien monsters in sci-fi movies. They look particularly terrifying. Now, these spines contain large amounts of keratin, providing a protective function, including their tongues and palates, which have leathery layers, so camels can directly chew thorny foods, grinding the thorns together and swallowing them. That's how bold they are. However, this diet is honestly quite poor. Then, additionally, when male dromedaries are courting, they have a very peculiar behavior. Male camels will expel a red sac-like thing from their mouths. At first glance, it looks like they've vomited out their stomach or liver. It's particularly gruesome. And after spitting it out, they vigorously blow air and shake it, making that thing produce very loud gurgling sounds. This is said to be the male camel's courtship signal. It's quite alternative. Of course, that thing is definitely not any internal organ. It's a structure in the male camel's throat called a dula. It's an air sac that can be inflated like a balloon. So why does this thing attract females? It's really hard to explain, because when it comes to animal sexual selection, tastes are always bizarre. There's no real reason to speak of. If I had to guess, I feel it might still be related to water. Look, when it hangs down, it looks particularly like a water balloon, right? And it also has gurgling water sounds. So whoever can blow it bigger and louder represents that they're not lacking water and are healthier. That's what can attract female camels more. I think it might be like this. Now, after successful courtship, camels' mating posture is also quite special. They use a kneeling position, and female camels need to be pregnant for about 12 to 14 months before giving birth to a baby camel. This is the longest among all common livestock. Then another thing, camels reach sexual maturity at an older age. They need to be 3 to 5 years old before they can start reproducing. In comparison, for cattle, generally 1 to 2 years old is fine. That is to say, camels' reproductive efficiency is also the lowest among various common livestock. This might also be one reason why they haven't become as widespread as cattle and horses. Of course, in those relatively arid regions, camels are irreplaceable by cattle and horses. Let's continue.
The earliest human domestication of camels was about 5,000 years ago. In Somalia and Arabia, dromedaries were domesticated. Then about 4,500 years ago, Bactrian camels were domesticated in Central Asia. Now, the primary purpose of domesticating camels at that time was, of course, for transportation, right? Especially in desert and semi-desert areas, long-distance transport without camels would have been simply impossible. You could say that all ancient trade routes crossing deserts, including the famous Silk Road, were walked out step by step by camels. The exchange and development between Asia, Africa, and Europe definitely owe credit to camels, that's for sure. Of course, besides transportation, camels also take on some other roles. For example, in ancient warfare, there were camel cavalry. It became a classic battle example of cavalry defeating cavalry. Although camels can't charge like war horses, they win in being large enough in size. A skinny camel is bigger than a horse, right? So when camels charge, the opposing war horses easily get startled. Then the battle situation turns around. And there are indeed such records in history. It's equivalent to camels fulfilling the role of war horses. Then another thing, when not at war, camels can also fulfill the role of cattle and sheep. In many arid regions where there's no cow's milk to drink, they drink camel milk. Although camel milk production isn't as high as dairy cows, maybe only 3 to 5 kilograms per day, the advantage is that they don't need to be pampered with good food and drink. Even under particularly harsh conditions, they can still produce milk. For example, nomadic peoples in the desert especially depend on camels. In extreme situations, they can even survive for a month by drinking only camel milk. This is what's most important. Of course, let me mention this in passing. There are many so-called camel milk products on the market now with heavy advertising. Actually, the nutritional content is about the same as cow's milk, and they're extremely expensive. There's really no need to chase after them. Now, raising camels has another use, eating meat. But I haven't eaten camel meat myself, so I can only look at others' descriptions. It's said the taste is relatively similar to beef. Then the lean meat is a bit harder, but it's the type that gets more tender the longer you cook it. You can cook it for a longer time. Then a big specialty of camel meat is the hump area.
As we just mentioned, it's all fat inside. You can cut it into pieces, marinate it a bit, then roast it. It looks like it might be a bit greasy. I feel it's probably similar to roasted lamb fat. If any friends have eaten it, feel free to leave a comment and share. Alright, that's all for the topic of camels. If you think this channel is pretty good, don't forget to like and subscribe.